All right, in this worksheet, this is worksheet number 13. We'll talk about permutation and combination. In the previous worksheet, we learned about basic counting rule. To count the cardinality of sample space, we want to see how many things are in the sample space. Sometimes, suppose that someone's password consists of 5 uppercase letters with no repeats. Okay, what is the probability that you guess the password on your first trial? We can use the basic counting rule. Right? You're choosing 5 letters, so pick the first one times the second one, number of cases for the second one, then third one, so on and so forth. But we'll investigate more convenient way to answer these type of questions by studying this special cases of basic counting rule. All right, so let's do a little bit of a review of the basic counting rule because it's kind of important. All right, let's look at number 1. It says how many different ways can letters of the word cat, C-A-T, somebody loves cat maybe, be arranged to form a 3-character password. Draw a diagram to illustrate the sample space. So again, we have 3-letter characters, so we have to pick the first letter, we have to pick the second letter, we have to pick the third letter. So it seems like it's a multi-stage experiment. I'm selecting 3 items. So I'm going to have 3 layers of a tree branch. So I'm going to start from here. So my first selection, it could be C, it could be A, or it could be T, right? C, A, T. So I can pick my password starting with C, or can pick my password starting with A, or I can pick my password starting with T. So that's my first layer. I have 3 choices. Second character, if I have chosen C, then I have either A or T, right? Because I already used C. If I've chosen A, then I have C or T for the second letter, and then I have A or C for the second one, right? And for the third layer, I'm gonna just write it here, probably need more space. So if you look at the very top branch, I used C, I used A, so I only have T left. Let's look at the second branch. I used C, I used T, so I only have A left. Okay, I used A, I used C, and I only have T left. Then I used A, I used T, so I only have C left. So on and so forth. So this one, TA, so I use C, I need C, and then TC, so I need A. Okay, so third branch, if I look at the first layer, I have 3 choices. Second layer, I have 6 choices. And then third layer, I also have 6 choices. So it's basically a basic counting rule. I have 3 choices for the second one times 2, and then times 1. So that'll be 6. For the second layer, this time is 2 because we already used the first letter, so we only have 2 letters left. And then for third layer, we only have 1 left. So that's why it's times 2 and then times 1. So it's not 3 times 3 times 3, it's 3 times 2 times 1. All right, let's look at the next question. How many different ways can letters of the word literacy can be arranged to form 8-character password? Here, okay, it's going to be hard to draw a tree diagram, but I can see how the first layer, there are going to be 8 letters available. And for each letter, for the next layer, they're going to have 7 letters available because you're not repeating anything. So 7, and then keep going, 6, 5, 4, 3, 2, 1. Again, it's going to be 8 layer. That's why I wasn't going to draw it. It's going to be too much space. But so whatever that is going to be our answer. How many different ways the letter can be arranged if you have 12 distinct letters? Again, it will be basically the same thing. 11, 10, 9, 8, ... Feeling lazy, to 1. So this is, there are some cases where it's going to have this nice pattern where we use the first item, then like we cannot use that item. So the second item, for the second selection, we only have one less selection, and so on and so forth. So this is case of thing called, this kind of case is called factorial. So in the previous examples, we got a bunch of letters, we arranged different ways, arranged a fixed number of items to form a sample space, right? So you have either CAT, we arrange it different way to create a password, or it could be 8 letter, or it could be 12 letters, whatnot. If we have n many distinct items, there are, so it's going to be like n times n minus 1 times n minus 2. We keep going down, right? All the way to 1, many different arrangements. This calculation is called the factorial, and symbolically written by n exclamation mark. In mathematics, we're going to call it n factorial, right? So factorial is just n factorial is n times n minus 1 times n minus 2 times all the way to 1. So you just keep multiplying smaller and smaller numbers until you get to 1. It represents the number of arrangements of n many distinct items. An arrangement is where we place items in a particular order, and different orders will result in different arrangements. So for example, our first example, we had cat, C-A-T, but if you look at act, A-C-T, they have same letters, but we're just arranging it different ways. So when we arrange different ways, it just gives you different result, right? Obviously, cat is different than act in terms of password. So this is called arrangement. We're just putting in particular order, and how many different arrangements we can get is represented by n factorial. All right, let's do some work here. Work on problems. Christmas gift number 4. How many different ways can 7 different leftover Christmas gifts be distributed among 7 people? Each person gets 1 gift. So we have for the first person, so I'm gonna again, I'm not gonna draw a tree diagram. First person, there are gonna be 7 gifts available for the first person, and I'm gonna have to pick for the second person. Again, same situation. First gift is gone. Now we have 6 gifts left for the second person, so 6. And then third person, there are only 5 gifts left, and so on and so forth. We keep going down, and the last person, really, we don't have a choice. The last person, there's only 1 choice for the 7th person. So 7 times 6 times 5 times 4 times 3. Again, also known as 7 factorial. You can use your calculator to calculate this out. That'd be your shortcut. So most of you guys will have that factorial function key on your calculator. So it's gonna be 5040 different ways. Okay, let's look at number 5. Christmas gift. How many different ways can 7 different, okay, seems like it's almost same question. 7 different leftover Christmas gifts be distributed among 3 people. Okay, so there's only 3 people. So what's the difference then? Instead of having 7 people, I'm gonna have only 3 people. So first person, second person, and then third. So first person, again, I have 7 choices, and then 6, and then 5. That's it. So I'm gonna stop here. Again, here I don't want to say it's 7 factorial, because 7 factorial means you have to go all the way to 1. Here I'm stopping at 5. So this one has this doesn't have a nice symbolic answer. We'll talk about this case later, but as of now, it's just 7 times 6 times 5. Number 6, how many different ways can 5 people line up for photo? So I'm gonna have you try number 6, 7, and 8. Okay, so once you're done with 6, 7, and 8, let's get back to our next topic, which is a permutation. So remember how for number 5, we couldn't use factorial per se because it didn't go all the way to 1. It stopped at 7, 6, and 5. It stopped at 5. So we're going to address that type of question. So permutation, when using factorial, we need to have n many distinct items, and we need to use all the items, right? So for number 4, we used all the items. There are 7 gifts, and you have to use all 7 items. So we could use 7 factorial as an answer. So when we're saying we need to have when we're using factorial, we need to use n many distinct items, and we need to use all the items. Make an arrangement. What if we don't use them all? Then you'll use a thing called permutation formula to account for that. Okay, permutation. When we are selecting R many items from n many items, distinct items, to make an arrangement, permutation gives you possible number of arrangements. Symbolically, it's written as, so I'm going to put n, p, r. Here I'm imagining we're selecting R many items out of N. So there's my R and there's my N, right? And then P for permutation. So symbolically is N, P, R. So the formula is, the way it's actually been calculated is N factorial, N minus R factorial on the bottom. I know it's kind of complicated. Side note one, in terms of calculation, we can just leave your answer symbolically or use a calculator. Most calculator function key has the NPR function key in it. Usually this is under like math or is under probability, right? So it depends on what kind of calculator you have. Side note two, if you're selecting on all n items out of n distinct items for arrangement, we can just use n factorial, which is just factorial was you're using all the items. But or we can do npn. Both will give you the exact same answer. So let's revisit number 5, 7, and 8. We did number 5. So let's see number 5 again. We only use, there were 7 gifts available. We only chose 3 out of those 7. And we arranged it a certain way. So if I were to revisit number 5, I'm sorry, I'm going to say 7P3. So out of 7 items available, I'm only selecting 3 instead of this. If I were to revisit number 4, I could have said, isn't it just 7 items available? I'm picking all 7, so I can be 7P7. If I calculate that, we'll get exactly the same answer. So I could have done that. So I'm going to have you pause and see if you can do number 6, 7, and 8 by using permutation, represent that by using permutation formula. Okay, once you're done with number 6, 7, and 8, again, then we'll meet back. And now let's get back to our new topic, which is combination. For the factorial and permutation, we're looking at the arrangement of items. Again, arrangement is when we place item in a particular order. If we switch the order of items, then will result in different arrangement, right? So for example, like CAT is different than ACT. We switch the order and then it will give you different arrangement. However, there are cases where we only care about what items are selected, not the order they're arranged. In that case, we say the order does not matter. Does not matter. So combination. We are selecting R many items out of N many distinct items, but the order of selection does not matter. Does not matter. Combination. So we have different name for that type of situation. Combination gives you a possible number of selections. Symbolically, it's written as NCR. So instead of P, we'll use C for combination. Combination formula is basically N factorial, N minus R factorial, and then R factorial. Again, like in real life, I'm not going to calculate it by using formula. I'm going to calculate it by using calculator. So number of selections for combination is fewer than number of permutations. That's just general statement. So similarities and differences. Both permutation and combination, we are selecting R many items from M many distinct item. That means that no items are repeated. So again, previous example, CAT, A was not repeated, so I cannot do CAA. That was not possible. Same for the gift. When I give away gifts, you are assuming all 7 gifts are different, so I cannot give away same gift twice. So no items are repeated. If the situation allows repeated items, then most likely we won't be using neither formulas. So no combination, no permutation when we have a repeated items. If you switch the first and the second items, then it does not affect the selection, which means the order doesn't matter, then it will be a combination case. That's the main difference. If it does affect the selection, then it will be permutation. All right, I'm going to have you try number 10. Just different calculations. I want to kind of explore different calculations and see if there's like a pattern or nice ways to calculate a certain numbers. So I'm gonna have you pause and work on number 10. After you're done with number 10, let's look at the next set of questions. Let's see if we can look at number 13. It says, how many ways can I select 3 people from a group of 25? Each person receives $50, okay? So again, I'm selecting 3 items out of 25 items. In the combination and permutation, they talk about like order of a selection. So if they're all getting $50, it kind of doesn't matter. Let's say if I pick Nick first and then Cindy second, right? Versus if I pick Cindy and Nick, in this particular case, they're both getting $50, right? So it kind of doesn't matter. Or let's say this Juan, it's third person, Juan. So I switched the first 2 items, Nick and Cindy. Well, as long as they all get $50, it doesn't matter if I pick Nick, Cindy, Juan, or Cindy, Nick, Juan. They're basically the same choices, right? So there are cases where this selection are basically the same selection, even though Nick and Cindy are swapped. So number 13 will be combination type of question. So for number 13, I'm going to say, yeah, 25C3. So that's an example of a case where we have to use combination. Okay, I think we're pretty much done. So I'm going to have you pause and work on the rest of worksheet number 11 through number 21 or 22. And that'll conclude our worksheet.